I'm going to cover how we went from this to this. Today we are making the ball mill. I'm going to go through the problems, the solutions, and the test run and the results, so to speak. Let's crash straight into it.
Mix fingers back, and we're going to assemble the ball mill today. We have everything here that we need. So basically this is the ball mill's core. This is the soul of it, which is the milling chamber or the paint can. We'll have this pinion rack here that is around it, screwed in from two sides. Basically it is a two-part thingy. And I have this as well, which is the counterpart of this, just it doesn't have the pinion rack on it. It will be basically put here on both sides, screwed together, and it has holes. That one will have holes as well. I'm going to drill it in a quick session, and when it is done, I'm going to, it's weird, but I need to do it with left hand. This will be put on there. The screws will go in, and the whole thing will be able to rotate around this freely, giving it a good axis. I have also a gear rack, a gear train that I will use to combat the, so to speak, high. It is like 300 rotations per minute to, let's say, under 100, so sub 100 rotation per minute, which is more optimal to ball mills. And using this, so small, big, that reduces the RPM, increases torque, and we want that because we need quite a lot of torque to rotate this with the contacts inside. In the past I have used these rollers, but these have not served their job well because they were not supporting the ball mill with like a single axis. That's it for about the talking. And what I wanted to say here is in the beginning that it is hard. And that's okay. This is what, if I watch these videos back, I'm just going to think that yeah, these were the things that I was struggling in the beginning, and these are like childish to say because these are like simple things, simple to understand, but not easy to do. These are like simple concepts like a gear track, and all these bushings, all these stuffs are like easy in that sense that it is easy to understand but hard to execute even because the eccentricity and all this, the material science, so to speak, too. So yeah, uncertainty is the one thing that is constant, and I just going to leave you with that, and going to do a time lapse whilst I'm like building this whole thing. Hopefully we will be able to like it. We'll see.
Here I'm trying and fitting the gear track to the ball mill's end because I didn't have a long enough shaft, so I had to reprint that and then drilled holes onto the pinion rack to be able to screw the screws in. Fitting the slide ring together to the other part, screwing in the screws, of course, and then assembling the whole thing with the cap. Assembling the gear track, or the, so to speak, gearbox. Then disassembling the motor control to put on the motor controller board. Now I'm drilling the supporting holes so I can screw it, fix it into place. Doing the electrical things, basically connecting the motor controller board, this LM298 board to it. Now I'm doing the wiring so I can connect the 12-volt power supply to it. Hooking up the VMOS and testing it out. So, I do not know if you're liking this shit or not, but I have assembled the thing. I have the power on. I have the VMOS running. I'm going to turn this bitch on. If I am correct, I do not know if this is full power or not. We'll see. I have no clue. We'll test it out. Turned out the RM board was too weak and did not supply enough current. The problem with the starting is that the gear track was brand new and I couldn't spin it up to speed. Also the bushings were fresh, so it didn't really have that much play to it. It was quite stiff, so the first start was, as you have seen from the video before, it was quite hard to initiate. And because there are some misalignment at the connection between the pinion gear halves, it was harder to start off. And what I did is that I have cranked the amperage all the way up to 10 amps. Then the motor spun up. Another issue came. 10 amp trial was done with the PS who directly hooked to the motor because the LM board was too weak to that. Did the 10 amp test, spun up, the gear just came off immediately. Reversed the polarity, gears came off. Then I thought about why this could be, and turned out that it doesn't matter which direction it spins, the nut that holds the gear's hoop into place will always want to move forward. So you need to put a counter nut into place and screw them together, tighten them together so that they have a tight connection, a tight locking that is on the shaft's end, which is a threaded shaft after all. And then I could connect the hoop up and it didn't spin off. And that way I was able to first limit the current to like 3 amps, did it to 12 volts, spun it up. Problem was that it slowly started because again everything was brand new, it had to wear in, slowly ramped up, then it kept going on and on and on and on and on in terms of RPM, so it was really spinning up high, it was kind of getting to wear itself in, and then I have reduced the voltage, we set it to a voltage limiting, constant voltage, CV mode on the power supply. Basically I turned it down first 6 volts, then 5 volts, then went down to 4.3 volts, which after all slow enough so that the balls didn't fling out and the centrifugal force didn't pull them out into the can side, so they were falling down and crushing the mix inside. So Mason is back, and sorry for the ear raid, but the drum is rolling. I have used a fuck ton of industrial grease, and I had set the settings to 410, and it was around 4.3 or something like that. It was drawing the same amount of watts. Now it is drawing a bit more current, but that's a bit better because we have a slower rotation speed, which is better overall. And yeah, even if we had the same wattage, this is a better setting for, as you can see, we need to be around 1 and 2 RPM per second, so, or like rotation per second, because RPM means rotation per minute, so that's probably bullshit, but you get the point that we need around 1/2 to be able to, as you can hear, the balls like crushing the thing. If I took it down even further, I'm going to reduce it slowly, not going to jam it. You probably can't tell by the visual, but like you can hear it. As you can see, the amplitude is increasing. Same amount of voltage is being drawn. Let's go down to 4 volts. Still going. Thank God yesterday I have warmed it up in, so now it can basically start with this, as you can see, if I shut it off and if I power it on, it basically gets up in no time, and the whole system is working. Yesterday it required a lot more energy. It draws like 2.8 amps to begin, but even that is not that bad. This motor can take a lot of beating. So yeah, I'm really proud of my achievement with this. It's not a big thing in terms of like mechanicality, So I got these 4 pieces of steel, these L-shaped profiles that I have made from like steel that I have found around the workshop, and I'm going to insert them in the inside of here. They will act as ribs that will stick out, and when they turn, it's kind of like with concrete mixing. You want the balls and the things, the particles or the things that you grind actually to travel up, and as the balls travel up they will fall from higher, and that will have more of the crushing power rather than just going up to like this. I don't know how far, but with this they travel up further and then they can fall down from further, thus have like higher momentum and higher braking power. With long suffering, I have made the rivets, and basically, first of all, made these ribs and installed them with holes and rivets, as you have seen, and now bores out of this and fill it up with filters, and so we can start bowling tomorrow. A ball meaning the already crushed fruit or the remainings of it. This is the most of it gonna come out, so it's not that irritative, and gonna show you. It looks like cocoa powder or cocoa powder. I don't know what that's called. It's kind of, I have sieved it with like a fine sieve, and this is it. This is like 150 grams. Crush all of it down, so I will have like a fine powder, and I will be able to apply to the or put into the ceramics, as I mean probably into the in the glaze, as well as the crucible that I will make. It will be useful to act as like grog, so it fills it up and continue ball milling it down.